Hey data scientist. So let's get into the very first question, L1 versus L2 regularization. Which one should you use? So I hope by the end of this video, you know how to answer questions like what are the differences between them, how do they affect the bias variance trade-off, and whether you can combine them. So before we get into these type of mathematical formulas and stuffs, let me explain you what the regularization is and what's the meaning of it. So basically, imagine you're training a model and it's memorizing your training data perfectly, getting super high accuracy, but it's failing on the new unseen testing data, which is what we call as overfitting. So the regularization adds a penalty term to your loss function so that it discourages the model to be complex, and it adds the penalty for making your model too complex. So normally we think if my model performs worse on training data, it should perform worse everywhere else, right? But actually performing slightly worse on the training data often means it's performing much better on the new data, which is what the regularization reality is. Let's get into the first one. On the left hand side, you can see the L1 regularization, which is also known as the Lasso regression. It adds the sum of absolute values of the parameters as a penalty. So the key insight here is, as you can see the diamond shape, the L1 creates the sparse solution. It literally sets some parameters to exactly 0. So when we get into the animation part, you can clearly see how it happens. But just remember that it sets the parameters to 0, which makes it perfect for the feature selection because it automatically removes irrelevant features from your model. So just think it as a strict editor who says cut out anything that's not absolutely necessary. So this simplifies your model, which is great when you have lots of irrelevant information. So just remember this way: when you have many features and suspect many are irrelevant, or when you need feature selection for the interpretability, you can use this. But be careful that if you're too aggressive, you might cut out some important part of it. But when you believe all features are somewhat relevant and you want to keep them while preventing overfitting, then you go to the right side of this image, which is the L2 regularization, or we call as the rich regression, which uses the sum of squared parameters as the penalty. So unlike L1, L2 does not eliminate any of the features. It basically shrinks them proportionally. So all features remain in the model, but their weights become smaller. This creates smoother, more stable models. But if you tone it down too much, you might lose important information. So the left-hand side, which is the L1, the diamond shape, means diamond shape has sharp corners at the axis. When your model tries to find the best solution while staying within the diamond, it often gets stuck at these corners. So being at the corner means one of your parameter becomes exactly 0. So this is why L1 regularization does the feature selection, since making the features, some of the features to 0 and removes them. If you come to the right hand side, the left one has the circle. So circle means it's smooth with no sharp edges. So when your model finds the best solution on the circle, it really lands exactly on the axis. This means both the parameters stay active but get shrunk down proportionally, which is smooth. So L2 keeps all the features but make them smaller and less extreme. So now if you look at these formulas, it will make sense to you. So now the sweet spot is when the regularization helps you to find out the optimal balance where the total error is minimized. So you might wonder why the bias is squared over here. It's basically because of this mean squared error formula, which comes directly from its mathematical derivation. I hope you can able to understand this derivation. If you don't, please comment it and then I can explain it in the next video. So can you combine them? Yes, you can, which is what we call as the elastic net regression. It gets the benefit from both. It can remove the irrelevant features while keeping the groups of related features together. It combines the L1 and L2 regularization using a mixing parameter called alpha. So when the alpha is 0, it's pure lasso. When the alpha is 1, it's pure ridge. So values between the 0 and 1 gives you the feature selection and smooth shrinkage. To sum up everything we've talked about, so during your interview, you can start off with the geometry part where L1 has the diamond shape, which has sharp corners at the axis. So your model tries to find the best solution while staying within the diamond. It often gets stuck at these corners. So being at the corner means one of your parameters becomes exactly 0. This is why L1 regularization does the feature selection, so we can use when the feature selection is needed, while L2 is the circle that's smooth, has no sharp edges, and it proportionally shrinks the features while reducing the weights. So to give us use case scenario, you can start off with the, for example, predicting stock prices with 100 features. The first scenario, no regularization, meaning the testing score is kind of low, but the training score is super high. It's overfitting, obviously. We can first apply the L1 regularization. In this example, it zeroes out the 80 irrelevant features while keeping the 20 of them. So this eliminates the noise features while keeping the important ones. While applying L2 means it keeps all the features, the 100 of them, while giving them the smaller weights, proportionally shrinking them. So the smooth reduction in all the weights prevents the overfitting. And one more thing, as we've mentioned about the elastic net regression, the alpha variable is only used during the elastic net. Otherwise, we have this lambda everywhere else, L1, L2 and the elastic net. So we can see in the next video how we can control these parameters and how we can find the best parameters to find out the best optimal points. Thank you for watching the video.